Hello, everyone, and welcome to my stream today. Sorry, I'm running late. Probably a surprise to no one, but when you decide to do a stream on trying to break stuff and you try and do a little prep, you realize you end up breaking stuff while you're trying to prep for breaking stuff. So, um, I've been I I've been doing a lot of bug fixes the last couple days, um, and in fact, I was trying to release a new version of Solid right up to the line of the stream, and I actually did not get there because I found another bug, and then I found another bug, and all this kind of stuff. They're all fixed, but I actually have to do a release right now so that we can continue on with the stream. I'm just doing a quick check here in the background to see if make sure sanity check all my change logs and versions. We're gonna have Solid 2.0 beta 1 here in a second. So let's make sure that looks good. It does look good. Okay, perfect. So this is version 2.0 beta 1. Come say hi in the chat. We'll hear. We'll get to stuff. I I actually prepped some notes for this one. I'm actually pretty excited. This is a pretty important stream. But unfortunately, a couple of my examples and stuff I actually are still sitting on my dev of the computer. I have two computers generally that I do most of my work on. I have my MacBook Air that I've been running forever, where I do all my like real work, and then I have my work computer, which I do my streams on, where sometimes I'll do some like long running tasks, but like it's not usually where I spend most of my time. And that means we're on the stream, so we're on that computer. All my intermediate ideas, examples are on my other computer here. So I need to push them up as we go, but I think it'll be fine. Solid for mobile apps. Uh, there's native script in Tori if that's what you're interested. We have a universal renderer. This was actually something that's funny that came up. Someone's like, and I think it's because Svelte's been talking about recently. Svelte never had a universal renderer. They didn't have like a like if they had like a 3D GL kind of thing that like Rich made himself, but they didn't have like a thing where anyone could just go very easily and like say make mobile or terminal or whatever other platform. And that's actually not the case with Solid. And Svelte actually is releasing their universal version right now, so it's like a bit of news, I guess. But the reason they can do it is because they took the same approach with Svelte 5 as Solid did. So yes, we've had a universal renderer since basically the 1.0 release about 5 years ago. So yeah, this is not a new capability. Some people associate it with 2.0. So yeah, look into our native script integrations. We definitely support mobile. Love the intensity of trying to release something, bringing every issue to the forefront. Maybe love is too strong. Stream-driven development. Yeah, you know it. Loading makes you think that the inside is showing when it is loading. Ah, yes. I see. So you're saying like the semantics are opposites. Yeah, I was hoping the reason I chose loading was because I wanted to pick a name where, when someone's like, damn, I need to ship, like, what's the first thing you think of when you're like, because this stuff is kind of optional. It's like you can build the UI out using signals and using everything. And then you're like, I need to actually show a loading state. I figured loading would be the term, or load or something would be the term someone would search or look for when they're like, how do I, like, or AI look for when parsing docs, when they're like, I need something to handle this. So that's why, because like suspense doesn't mean anything, right? But yeah, like what is suspense? First of all, suspense has specific behavior that React has that we do not have. And secondly, it doesn't really mean anything. So even React doesn't like the name suspense. They said if we did it again, we'd call it placeholder, which I was debating as a name, but that confused other people who are more DOM centric because they're like, "Oh, we already have placeholders," and I was like, "Okay, well, what are you doing? You're Because the problem is leaving it named suspense is confusing because people would think it would behave like suspense and it doesn't. Error to error. Yeah, I just wanted a shorter name. Error boundary sounds so like, again, like I was gonna call it error, but error is a is like a built-in class. So like you'd have conflicts. Yeah, so human natural renames exactly because and we'll talk about this a bit when we talk about AI, but human natural renames are actually valuable. I mean, the funniest thing is, if you asked me this question about solid start or tan stack start, um, I would have been like, oh, like I'm trying to like pad the estimates and like trying to figure out like because I'm probably not the one doing the majority of this work. There's people who already have like semi-working prototypes like the day after I released. The speed at which things work in the age of AI is completely different now. But is that stable for you to use? No, I mean, obviously not, but is kind of crazy. I like I can't give you an exact estimate. Just it's sooner than any estimate that I would have expected to give you. Yeah, ref change. There's a lot of great changes here, and we'll talk a bit about them as we get into the next part. But I the one thing that I haven't been seeing on Twitter in the past when I posted stuff, people would kind of generally maybe because I had all the early adopters and people in the stream coming, they kind of get it. I think people are really missing the big picture here. Like I think obviously I get excited about new technology. Everyone knows like I get super excited about new technology, but I don't think people realize just how big this is. I'm not usually someone who's like really good at marketing or pushing, along, like I don't know how to do this. I'm gonna admit that to you guys right now. But I feel what we're doing here at Solid 2.0 is a bigger deal than what we did with Solid 1.0. Um, and when you consider the impact of Solid 1.0, like I'm not talking about like how popular Solid is, but when you look at how it's impacted the whole course of direction of web development in the front end, um, I think that's saying a lot. Yeah, so yeah, I'm gonna make it hopefully crystal clear if you bear with me for a few minutes why this is such a big deal because people are like, oh yeah, AI, blah blah blah, and it's kind of funny. I know when you get into something, you're like hyped, and I am super into AI these days, so I get the hype. But AI for me is becoming an understood thing. This I don't understand. This to me is more exciting than AI at the moment. Like in itself, AI is like getting excited about TypeScript. Like I get excited about TypeScript because like to the degree that like how it feels writing my code. I don't get excited about TypeScript because it like completely changes the way I can view like the architecture of my app. Like don't get me wrong, like AI's got me really the way it changes the way I can develop. I did the last like couple streams talking about it. Super super stoked. But this is like a completely arguably equally exciting thing that is completely orthogonal. It's not like one replaces the other. These are just two really exciting things happening at the exact same time. Yeah, you saw that comment. It's funny. Someone thought solid widget adding normals. It was like the universal thing. Most people don't realize just how full. And I told you I'm terrible at this. How fully featured Solid has been for years. Every time people get really excited about like features and other frameworks, and they come in, they're like, oh yeah. I think sometimes they do it to be like, oh, I would try Solid, but you need like you know there's a certain thing that always happens with like smaller solutions. They have less people, so generally they're less fleshed out. They have less ecosystem. It all makes sense, and it's chicken and egg problem, right? You can't grow until you grow. And but technically, from a technical solution standpoint, Solid's been always really really good. So like it's quite often really interesting when people come in and they're like oh, I'd use this, but this, you don't have a Next.js, you don't have this. And honestly, that list, I was filling out that list for years and years and years and years and years. Um, and the funny thing is, I actually finished the checklist a couple years ago, right? And I finally got the change. I finally got to be like, okay, what would I build if I didn't have to cater to everyone's like checklist? The funny thing is, people are still coming at me with the checklist. They just don't realize that the checklist was finished ages ago. And ironically, because a lot of frameworks and solutions have changed to be like Solid, the new stuff that they're learning now that they're where we are is stuff that we've had for years. It just keeps on happening. Like, as I said, like Svelte Universal. It's like, yeah, Solid Universal 2021, like you don't need a virtual DOM. Yeah, exactly. you know, like, so it is kind of funny. I get why people would assume it's the other way, but it's almost like the opposite assumption. And I know this is a crazy thing to say, but you're almost better off to assume, like as a base flag, that Solid can do everything that every other framework can do better and before they did. I know that's like it's not true, but just if you came in at that baseline, you're probably like closer to the truth. Um, which sounds really cocky to say, but I, I mean, go collect the facts, you'll see what I'm talking about, right? I mean, from a mechanical standpoint, that I don't think I, I I think you just have to kind of um I don't know how to reset the expectations of people. Maybe because I don't come off and saying solid is the best all the time or something. Like I rarely do. This is probably the heaviest I've laid that on ever. It's not in my personality. I don't know how I said I'm bad at this, but that is kind of a better place, maybe like a more accurate place. It's not 100% accurate, obviously, but I think that's almost a better place to be like as your baseline. I think so to change when market because I use some program, but not AI is very different. Yeah, AI is changing the way we can build. It's changing our nimbleness. To me, it's not funny. It's infuriating. Well, and this is all going to come together because as I said, you have to bear with me a few minutes to actually get to my point. I wrote some notes, and I apologize, and I'm really trying to do the solid release in the background here. Sorry, V2 beta 1. That looks correct. Um, and then all I need to do is pm uh, publish tag next. Yeah. I think that's it. Tag next. Oh no, that's not right. I need to do it recursive release. Sorry. Npm publish. Sorry, give me 2 seconds. I just want this stuff to be going on in the background so we don't have to worry about it. Oh, right. Damn it. Freaking auth tokens like every freaking time. Give me so this is the last thing. Sorry, the break. Uh every freaking time. Too slow. Okay. All right, cool. Oh, hey, sorry. I'm just like just getting started. I haven't even opened my Twitch window up. It was that a raid? Um, um, sorry. I'm a little scattered this today because I've been It's like the stream is hopefully the culmination of like months of work and realization. And the funny thing is, even when you do this stuff for ages and you kind of like work through this, you don't really realize. Um, yeah, maybe not. You don't even realize like the implications until the last minute, right? It's like you kind of have a fundamental hunch. You have like a sort of how should I put it? Like a suspicion, an architectural like I don't want to say like assumption, but you have like a certain like intuition, and then as the pieces start fitting in and they align, you start being to see bigger patterns out of it. See, the funny thing is, it doesn't matter how many times I say the same thing. Solid on native when we literally for the last 10 minutes I've been talking. I'm sorry, I'm not to call you out specifically. It's just the funniest thing is it's like this isn't even like a new thing. This is like something we've been able to do for years. So it's like, why are we so bad at marketing? Like, why are we so bad at getting the message out? Um, it's a real struggle that I've had. I think a large number of people have some kind of assumptions or like lack of knowledge. I can't get it out fast enough what we're capable of here. Okay, so what let's change gears and get started on the actual topic for today, which is I want to. I mean, I'm not saying the actual talk. The actual talk was the break stuff. We're going to break stuff in a few minutes. I actually want to talk a little bit. Usually, I'd wait to do this until we had like the 2.0 release stream, but we're in a different age right now. Everything is different now. Like the way we work, the way we iterate became very obvious while working on Solid 2.0 because like the traditional way was we would just like make a working group in GitHub and have people, like add comments, kind of like all the stuff I worked on in standards, and then we meet in meetings and whatever. Now it's all async, it's all Discord streams. Like we have different mechanisms to get feedback early, but our journey today did start that way, and I want to talk about it a little bit because again, this is the part you need to bear with me for a minute, because it's going to get somewhere, I promise. Okay, so let me present my screen. Entire screen, that one. All right, let's go. I don't know if anyone remembers this. July 23rd, 2022. Yeah, it's tricky because it's like third party, right? So maybe we need to link it. Yeah, right. Who's a DevRel for Solid these days? Um, the guys who speak, I mean, everyone's a dual role. I do a little bit, but yeah, I mean, Attila, obviously, but he also leads the Solid Start effort. Well, we still got Daniel out in the trenches, people going and doing like conference talk side. Then I think there's people like Brenly who write a lot of articles and do a lot of social posts, but so we have the bases covered by a few individuals, but yeah, I mean, it's hard. You need the kind of voice. Like when Tanner Lindsley retweets something that we post, that gets way more eyeballs than anyone directly related on the project gets. Do you know what I mean? So it's we don't have like we have people doing good work in these areas, writing newsletters, doing social posts and whatnot, but it's not none of us have the same audience that even just like, an off the cuff, quote tweet from Tanner kind of touches. The weirder the semantic and bigger the mind shift need to get there, the more mark you need to make click progress. I no, I get that. It just feels like you also could say that time could help. I always kind of was hoping that like people would just kind of get there over time. I have this is a flaw for me, I'm a systems architect kind of personality, right? I think of things that way. So for me, when something eventually, once I realize something becomes true, it becomes an undeniable truth. It's like inescapable for me from that standpoint. So for me, I kind of have a perspective that if people are left, maybe not completely alone, but kind of guided the right direction for long enough, they'll kind of figure out the truth, which is not really how marketing or anything works. It just for me, there couldn't be any other outcome. I don't know. Sounds weird, but yeah. I agree. You have an audience of right focused engineering architecture and rightfully so. I mean, it's what I care about. Right. So let's wrap this around. Okay. So this was something I posted July 23rd, 2022. This was like this is almost exactly a year after Solid 1.0. And I was like, you know what, let's drop this in chat so you guys see this. This was the starting of a work group because I saw that like React was having some problems, you know, in the ecosystem and people weren't being heard. I'm like, I want to make sure that people on board with Solid 2.0 right off the bat. And yes, I understand this is almost 4 years ago. You just have to understand that this is important for context. So I went through a whole idea of like what we like really fundamental things that we could review, you know, people might care about, like read-write segregation. Some people hate those tuples from React. Some people really like how you can do that thing in Vue, right? But I also said, like, look, this is the decision we've taken here. This is how important it is and how confident I am that we made the right decision. So for me, like something like read-write segregation, no two-way binding, all that stuff, like I am highly, highly confident we made the correct decision here, right? It is part of Solid's bones. But my point is, I kind of laid out, you know, setter functions, blah, 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 effects, render effect, create reaction, writing signals and effects generally don't do. I had ideas, at least, of what we should talk about. But there's stuff that I didn't get right, and we'll talk about this. Synchronous execution. Well, to be fair, the synchronous execution I'm talking about here is a synchronous propagation. Once you have committed the state, but I think a lot of refinement was learned over the thing. Effects don't run during SSR, effects and reducing, derivation, dequality. I went pretty deep here on this, but I basically used this to decide what our future work was. This is before I decided what 2.0 is. I was just like, okay, we got to get rid of create computed. This whole like writing to a signal in the middle of executing the signals is a mess. It's terrible. I knew that I wanted writable memos. I wanted to make some kind of, I played around with like getter setter patterns, but then I was like, okay, you know what? We could just, I basically came up with a form where you basically would get the value in the thing, and I call it create random thing. You guys might recognize this in the 2.0 things because ultimately we would fold this down into just create signal itself. But lazy memos, derived resources, there's a few key principles. I wanted to make sure that async flowed through the graph. I wanted to make things lazy. And anyways, we don't have to get into all the stuff. If you really care, you can come and look at this discussion that, you know, all of 10 people, or maybe 27 people looked at. My point is, this was an idea, but where we ended up was is very far from this idea. The thing is, the timing of this idea is important because this is 2 months before Preact signals came out, before Angular started talking about signals, before Quick changed to signals. Actually, Quick might have been around the same time here, but basically, this was what I thought the future would look like before anyone else adopted signals. And I feel like this mentality kind of, you know, and the way I was talking and the thing kind of influenced that direction a bit. But when I came around to actually implement it, I realized that like stuff like lazy, which I took very highly to be important, actually it wasn't that important. Most things ended up not wanting to be lazy. For example, like async, you know, has this problem. Like if you are lazy and you're reading from multiple async sources, you know, you might cause waterfalls, right? You actually want async to be eager generally if you want it to flow through the graph nicely. I mean, you could, you know, I had the core pieces, but it was a long time to get from this concept. And I feel like in the meantime, in between when, you know, I had this vision of the future at that point to actually implementing that future, almost everyone else jumped in the space. And suddenly, what started as very much aligning on future vision ended up being, I found myself in a very, very different place, if that makes any sense. Let's jump ahead to today. I just wanted to do a quick kind of loop over to this, but where are we? Some of you might have seen this article I wrote. Solid runs open codes 2E. Yeah, it's true. Yeah. The docs effort, I just didn't want to keep it out of people's hands until we got there. But yes, it's already underway. We'll definitely need help. Yeah, this post was not written with AI. I don't generally write with AI to for stuff that I actually want to publish. I know I used AI for the RFCs. Technical docs are places where I find it helpful. When I'm trying to tell a story, like when I release an article, usually I'm not going to use AI. Maybe to hope, like almost like Grammarly, but even then it's kind of dangerous. You lose your tone a little bit too much. Anyways, I'm going to drop this article in here. The important thing I want to point out, and this is moving this conversation forward a bit, is I identified that we have basically three main objectives in JavaScript frameworks right now. If you want to understand JavaScript frameworks right now, there's three main objectives. There's the AI first framework. There is the isomorphic first framework. And there's one more, the async first framework. Yeah, there it is, the async first framework. And I kind of coined, I mean, I coined the the second two terms, to be fair. So these are just arbitrary things that I made up a name for. But there are enough. We're not alone in looking into these different directions. Like different frameworks are working on these three main objectives. And I admit I didn't know much about AI even when I wrote this article. Again, I'm pretty good at filling the blanks by pattern matching. So I had a suspicion and I kind of had like limited experience to be able to do that. But what's changed for me in the last couple months and why I think stuff's why I think this stuff's very important is understanding that all three of these objectives are ultimately the same thing. They lead to basically the same thing. And I'm going to talk a bit about each of these with a current lens, so you can kind of understand what I'm getting to and how this relates to Solid 2.0, right? Like, yeah. Where do I want to start? Yeah, let's. I'm going to actually start with async first. I'm going to leave AI to last because I think that's what ties it all together. But um, it's funny as I've been working through this problem space, I realized that I always kind of knew this, and this is something that I think differentiates my perspective a lot from a lot of say developer like users of these systems. I think that as much as we can fault React about implementation, like the way that like the mechanics of the technology works, it is almost impossible to fault React on conceptual design or on design, which I already know, chat. You guys are already going to disagree with me. I already know that. But in the same way that I'm very like, what's the term, like foundational thinking, like first principles about mechanics, React is about API design. And it's very hard to find faults in them. The thing is, okay, ultimately, people find faults in React's API design all the time, but those people are just wrong. Sorry guys. And myself included. Like, I found over the course of working through the async problem that React, knowing that async was on the horizon, made API design decisions that are almost like they're inevitable. But everyone else was like, why are you doing this thing? You just make it awkward. We hate you. And we were wrong and we were stupid. I came across, yeah, three things while I was working on Solid 2.0 to that degree. Um, and they're the things that people hate the most about React. Like the fact that you can't read the value after you call set state. Like you have to like flush sync, or you have to do something, like it's just not present. You can't go like set count +1 and then see the new count on the next line. React is 100% correct about that. In a sync world, there's other mechanisms you can make sure that things read early, like signals and reactivity, but that doesn't make it correct. And it doesn't make it correct from an async stance, because when you have time as a consistency, you have to keep synchronous frames within the same scope of thinking. It's an unfortunate reality. Another example, the way they split effects, like where you have the dependency arrays. Now, you might not need to type dependency arrays, but conceptually, this allows them to know all the dependencies before they run any of the side effects. This is incredibly important for async because otherwise you don't know where the things are being used until you actually are doing the side effect. It's too late. This is a fundamental truth, right? Now, we can build compilers to detect this stuff. That's what Svelte 3 did. Svelte, like for people who don't know, Svelte 3 was basically like React. They basically had like compile-based dependency arrays. They just compiled them in. I think React compiler is adding that in. But there's a real cost there because now the things you compile in that you track actually have to be reactive or care about the reactivity. Like you lose the choice or control of that. Like with runtime detection, these things can be variable. Some things can be reactive or not. Some things can be reactive or not, depending on how the component gets used. Compilation has no knowledge of that and is extremely limited, which is why Svelte moved to Svelte 5. But it doesn't change the fundamental truth that if you want to be consistent through async, you need to know the dependencies before you run any side effects. This is just an actual undeniable. It's like gravity. Like if you guys think it's bad, argue. Like we can dislike that we can't fly, but I'm sorry, I can't help you. Like you can come up with clever. We can come up with clever, flying devices, but it doesn't change the actual physics. And so, like even more subtle things, like the way they handle refs as not being state. This is actually a really smart thing. So I just want to throw that out here because this is probably the most positive I'm going to be about React on this whole stream. I'm usually fairly timid on this stuff, but as I said, I'm telling you this to understand very clearly why I think React is amazing at designing. I'm not saying this because I think that React is the best approach to do front end. I just want this to be clear. Yeah, just checking thing, right? Later version. Yeah, and we can. I'll touch on it a bit, but they are very far down the thinking path here, and I think it's understandable that not everyone has gone as far down the path. A lot of people don't think they need to go as far down the path. We're having when it's hard to be like really down like a specific kind of avenue when other people like you created your own problems, now you're solving your own problems. Like like we wouldn't need a React compiler if you didn't force us to use callback and memos, and like both sides are kind of right. But on the other hand, there is fundamental truth to understand in this, like underlying fundamental truth. And if you don't have the complete picture, you can't paint it. I had a great discussion with the Critter Data Star this week, and it really became clear to me just like where things live in certain zones and how the universality of the like solution scope range drastically impacts how you look at, like, even for people who are architecturally minded. Web components actually is another great example of this. I had a great discussion with them a couple of weeks ago, where again, it's the scope of the range you want to work in is incredibly important, because you can always make assumptions within a certain range, but when you try and generalize, those assumptions can often fall apart. And I think it's important when we're solving engineering problems to like see that like both sides are fine, like are good. If you recognize that the scope can be contained, you should definitely go in on that, because then it's like, okay, I don't have to worry about this. You've already removed a whole like categorization of problem or zones, like everything out of scope is out of scope, right? But recognize that if the scope extends beyond that, the the truth can change. Exact is potential, and this is an exercise that I, play around with a lot. Okay. Okay. Useful to know where the improvements solid brings actually are. Getting there. Okay. So my point here, or what I'm getting to, at least on the async first side, is that like there is clearly a desire to kind of solve these problems, and um, React is actually right there with us. You know, oh, it's funny. I tried to save this link, but it's not working for me. Maybe I can like remove a few of these and see if that will fix it. We'll just remake the chart. I think you guys are familiar with this chart. If I just go SolidJS, looks good by itself. Let's add a few others. Right? React. Down we go. Oh, yeah, the site can't handle it. Let's try view. At Angular core. Preact again. Preact. Oh, we don't like Preact. How about React? Good. Okay, last time Preact. Let's do this. Okay, sorry. Sorry, Preact. Just know that they're up by a view. It doesn't really matter. But I want to make a demonstration here. Let's see, can we go 5 years? Okay, sure. We've all seen this chart, probably. I've seen it more than others because a lot of React promoters like showing me this chart, like I'm not aware of it. But I think there's something important here. Even by 2020, can we do all time? Can we do all time? I'm really forcing it. I lost React. No, okay. Now I'm losing view. Okay. Can't do all time. Let's stay with 5 years. Okay. Even if you go farther back, there was a time that Vue and Angular were about half as React, but you have to go back into around 2016, 17, 18 time period. Basically, since 2020, React has almost been triple the downloads. Now, I don't want to say trust downloads for everything. I just want you to just understand the sheer magnitude of this, because even if you ignore and definitely ignore these weird spikes that happen, but if you even ignore this weird 2025 curve up probably caused by AI and just keep on this linear path, no one was basically ever catching up to React on npm downloads. So not for any feasible time period. React has a lot of users. React is too powerful. Yeah. Come on, Preact, get in there. Get in there. Yeah. Okay, we got Preact. See, there it is. Preact now by downloads is actually the second highest. Anyway, my point is that I don't even think this is a great representation, but it definitely shows just on pure volume just how much more React there is out there. I honestly think that React would be exactly where, very close to where we are right now, what I'm talking about, if they could move. If you think about it, React had concurrent mode, and they knew about that 7, 8 years ago. Then they had concurrent features, and trying to they've been trying to address this topic for a decade inside their own ecosystem, and the reality is they probably wanted a concurrent universe, but they realized that this number is too big, right? Whereas most the rest of the frameworks we don't matter, realistically, I mean, if you put it in this scope against it, Svelte and Solid didn't even start mattering till about 2024. Like it's felt you see starts picking up here, and then solid starts picking up like mid 2025. Like 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 we are a drop in the bucket, you know. And like I actually think the real numbers are even more exaggerated than what we see here. So the thing is, React can't just do this. Even if they want to, it's going to be hard. Like that's the engineering challenge for the React team. It's not like whether they can do it. It's like can they feasibly do it? And you kind of understanding this helps kind of understand um, a bit better on like why there was a view 2 to view 3 or svelte 2 to 3 and then again svelte 4 to 5. Like how can frameworks change so drastically um uh and like you know be perceived as like, oh, I mean there was some tension on a few of those, but like generally like, oh, this is a good thing, by comparison, just because of just how small the bucket is. Like it just React can't do that very easily. This AI thing you could argue from maybe about here, like 2025. But if you go farther, the slope is actually fairly linear and at a greater speed than everyone else, all the way until when I would say AI really kicked in, which is the last like year. So, okay, what does this have to do with what I'm talking about? I just want to kind of point out like async first is something that I think React is working on as well. But we need to kind of understand like why this is important. And as I said, React felt ourselves are kind of in the same boat. This is where I actually wanted to grab that example that I haven't even looked at here. Let me just quickly pop something into a stack blitz. Let me new window, because I got AI to make me a React app. Um, and I don't know if I should trust it to make me a React app, but God, it didn't even. That's so sad. It didn't even. It didn't even. Whatever. I'll start the stack blitz. Give me 2 seconds. I'm sorry. I know I'm not on the same screen as you guys, but this is the last thing I need off this computer. I'll grab one of my React 19 examples and just drop the code in. And then we can work on it for a second on screen to show. Because if you guys remember on my last stream, we tried to take a very simple counter and let me fork this. React to-dos. Okay, and then comp. Let's call it comp. And then I'm just going to drop a couple source files in here, and then we'll be able to kind of finish the example, hopefully, in the browser in 2 seconds. And you guys are like, what? I came here to talk about Solid 2.0. Why are we talking about React? What's going on here? Yeah. I'm sorry about that a little bit. Give me a second here. App. Oh, what the hell? Sorry. Do A C A B, and then I want new file. Sorry, 1 second, almost done. To-dos.ts probably. The funniest thing about doing it this way is like I have no idea if if um if this example is even any good. We'll give it a quick look. Okay. Sorry, this is what I would have done already if I actually was not fixing bugs until the last possible moment. So let's stack blitz here. Okay. So um I'm trying to show people why async first is great. You might I'm going to do a quick recap from the sync to async stream here, but I made a silly example where you have state and a button that increments it, and then 5 divide operations that get showed in the UI, right? And it's pretty straightforward. I mean, you don't even really need to memorize these because they all update together, but you get the idea. I kind of sometimes overwrap when writing React code because I'm used to writing primitives like this, but it doesn't matter a ton. We basically just 16 divided 1 is 16, 16 divided 2 is 18, 15. It doesn't really matter. And what I tasked us with was, what if this divide function now had to be on the server? How would we change the code? And the answer was, we tried to do something very kind of like pre-React 19. And don't get me wrong, React 19 had some great stuff. But we actually made this kind of cool thing where you saw that when we loaded in, it had like a loading indicator. And then when we click, it gives us a pending, and it actually waits to all our clicks to happen to show the numbers. So we made this kind of fairly nice UI, with see, this is now returning a promise. And then we went through and we made an effect that did some data fetching, set a bunch of states, and then made those states, and then did a couple null check guards, and then wrapped this in a ternary to check loading. And then we also had a visible end versus end because we didn't want to show, we wanted to be able to show this 21 and start fetching before we actually showed it down here. So we kind of like forked the value into another state variable. And in the end, we got something really quite nice, right? So, this was kind of an illustrative case of how we went through all the edge cases. We had to make sure that we didn't have any race conditions. We do this thing where we like do cancellation using the cleanup function. We had to make sure that that and then we had to also make sure that like things updated together, which wasn't too hard. We used this promise all. We wanted to make sure stuff wasn't just flowing in, and that like we didn't show inconsistent tearing in the UI, and we went through all this kind of stuff. And then like the point of this example was, I had obviously previously made this example in Solid, and the funny thing about the Solid example was, if I took the original code and then just changed this to a promise, we got the exact same behavior without doing anything, right? That was the demo, right? And this starts to touch on why async first is so powerful, because you can, when you treat async as just another part of the graph, right? It's just something, this is what a promise of a number, and it gives me an accessor, a signal of a number. When you just treat it as natural part of the graph, okay, there is a loading indicator. We did have to basically indicate that we wanted the in-flight number, not the previous number. So there is UI changes here, sorry. So that isn't 100%, but we didn't have to null check the UI anywhere here. We didn't have to make a bunch of loading states. We just asked the question, like, is this pending? Then show it. We basically turned the async logic into declarative logic, and we're not the first person or framework to do this to various degrees. And like, I actually, big shout out to Remix, like Remix 2, not talking about Remix 3, like when they yet, but we will. When they introduced optimistic UI as state, that got fed back in, that was like the turning point of kind of starting to understand what a real model looked like here. So this is kind of related to that, but I'll get to why. Now, why was I just in here? Well, I was trying to build this example, a to-do app example. Now, I need to do a little bit of wiring. Rename this to use to-dos, it looks like. And then, is it use to-dos.ts? Yes. Are we okay now? Okay, so main imports app. App is, oh, okay, so let's get rid of this. So we just need to export app here, export default app, or not, or, yeah, I guess just export default will do. Export default. Oh, right, it needs the API. Let me steal that API from a different example. Let me go into here. I have a project here called Solid Optimistic Data with Affordances. Beautiful. I think this API TS is going to be essentially the same because this is our server backend. Okay. So let's add a new file, call it api.ts. This is the part that doesn't matter. It's just a background server. Oh, sweet. And then all we need now is to wire up our CSS. We don't have it. App CSS is probably the same. Let's just move that into here. Huh, we have a to-do app. Sweet. Okay. I mean, optimistic API UI is, it can be bad, but I'm getting there. There's something fundamental that we're exposing here, and I think we're gonna get there. So I I got AI to try and build my example here. Now I don't need this anymore. Hopefully it did okay. What did it do? Okay, so yeah. This is going to look a lot like the one we divide, because I just instructed it not to use React 19 APIs, but build it the way it would with React 16. So this is not a fair comparison of React. The reason this is a fair comparison is because this represents the majority of this that's out here. Okay, that's what that is why I'm doing this. And a majority of people who the same people who come in and ask if Solid has a native renderer are a lot of them. A lot of people might be still like in this zone. A lot of people who use CanStack, Query or whatever, like you've been able to benefit from mechanisms that the ecosystem have built on top without actually worrying about you need to do that without how should I put it? Sorry, I lost train of thought. I was reading chat and I got distracted. But what I'm trying to say is that um React is working very hard on these problems. So I'm not this is not when I'm talking about at the beginning of the stream is actually universal, not just a Solid 2.0, but I think Solid 2.0 best exemplifies a point in the future that where things are potentially converging. But okay, what I tasked it with building an optimistic AI. So or with things. So now we got loading state. So when we load, yeah, we got the loading state, and then in our to do item, use callback, use callback on retry on remove, and it's got the right state handling. The real question is when I do hello. Okay, good. So we've got optimistic UI with retry logic. Nice. Okay. So this is built. Right. This is, if you've seen this, I shared this demo a while ago. This is, come on, remove. Okay, we got to you there. This is a demo where requests fail half the time. But I instructed AI to try and build this demo essentially using like, yeah, it's not API. I want to use to do. It's using like React pre-React 19 APIs. Okay. So what is it doing here? You know what? The funny thing is, yeah, and it's actually pointing it out here. It actually didn't actually solve everything. Like this is actually looks fairly convincing. Because it fetches the to-dos and then it sets the to-dos and we apply the error. It actually copied the same pattern I used in the 2.0 demo, which I don't think a lot of people get there naturally. It's understanding that things are derived. I think most React developers actually wouldn't write it this way. I was telling it to write it like most React developers, but it's still not doing it. Bug, no cleanup. If the component amounts, well, a fetcher of action is flight, set state will be called. So, okay. Um, and then use callback, set to dos. What else do we have in here? This refresh replaces all to-do state with service on state. Any other in-flight optimistic updates toggle that hasn't been resolved yet will be aborted. The user sees their pending change will vanish, then reappear. Can we confirm that? Oh yeah. Did you see that? I mean, these failed to add, so it's not the best example. We have to do a rapid example where it doesn't fail to add. Oh, what? Did we end up an extra to do somehow? What? I think yeah, I think we did. Oh, this one's dead. Can we start over? Okay, yeah, this is what the state really should have looked like after all those actions. Um, it's because I did a multiple at the same time, so the race conditions basically killed us. Like this code actually looks fairly same concurrent clobber, so you had to do above, same concurrent clobber, so you had to do. This code actually looks fairly convincing that it would work, but it actually misses out. Okay, on a lot of things. No, come on, mounts. Bug, no abort handling. If two fetches race, the slower one wins, regardless. Yeah, you could fix this by adding an abort controller. Um, the thing is, I actually got AI originally to build like a perfectly working one that handled all the use cases, but they basically parodied the approach that I took with Solid, which is not very intuitive, like the internals to actually make it. The new is pending, so you need to recreate normal language conditions with new semantics. Yes, in a sense, we're turning this, we're pulling it in. Depends on endpoints make the default straight and nice, but all other logic comes more complex, no balance. I don't know if I agree completely there, but let's continue. I could understand if 90, but the hostile is turning off anything tells you to update the real yet is okay. Yeah, well, I'm not talking about React today. Be very clear. I'm talking about. It's so funny though. They use callbacks and stuff are things that I have a hard time thinking in. But the thing is, this this version is a reasonable stab, and I don't want to spend all everyone's time working through this. It kind of works until like you start hitting all the different race condition scenarios. Um, so yeah, suddenly abort controllers become really important, and like suddenly like you need to hold other state of references to understand the in-flightness of things. So like the reason I want to show this is because our divide example exploded, but it was the simplest example I could think of. This is like the next step up. It's not even as complicated as your real app, and it's exploded, and we still haven't solved everything. This like I really hope why async starts becoming important here, because this component code is like this could be a suspense boundary, or I don't like this part doesn't matter. I mean, you want to make it opt out, so then you also have to wrap everything in a transition, which is fine. You can put the transitions in your to-do items, wrap these callbacks to transitions. There are APIs to solve this in React 19. I'm just trying to show that like you could take something that's a bit of UI logic. This stuff is fine. Like is a pending, is an error, or whatever. Like this stuff's all fine. And then try and obscure the async layer and still have a very difficult time working through this. As Ricky's own demos, he's been trying to make demos kind of like this, where he's like showing like, look, how would we do this in React before? How would we do this in React today? And I'm using that same old React as the what do you call it, the thing you compare against. I'm not suggesting that. I'm meeting you where you're at, so to speak, so that we can talk about this, because The example in Solid 2.0, which does not have these issues, I mean, I pressed SDF 3 times. You're not going to see like you saw the last time we actually ended up with more items. This one, when everything's settled and I refresh, we're going to end up with the same thing. Like, you know what I mean? Like, it's not going to like think that it has new like random things that it lost track of and weird state desyncs and cleanup issues when things unmount and all this. And the thing is, this is basically the same, right? You know, solid syntax, you know, but you know, here's our logic around the loading stuff. This is basically the same, right? But the difference is the to-dos section where we had all that logic. Yeah, we have the error layering, but then it's like I'm creating an optimistic store, I'm setting a few actions, and everything is just handled for me. You know, this this is this is an example. Like there's some interesting stuff we're doing here for matching add, but generally speaking, the actions you do optimistically are the same as if the thing wasn't even async in the first place. You're like, if you want to remove a to do, how do the optimistic state is you filter it out of the list. If you want to toggle to do, you find it and then you set it as completed and get the fine-grained update. So, I mean, there is a secret other hidden difference, obviously, is when both systems are working optimally, Solid's version will still be more optimal because it's fine-grained. But like, that's not what I'm here to count too much. Like, I mean, but you get what I'm saying. Like, because like if I go in here and I write, go into like our to-do component and do something like console log to do, you know, then like we should see like console clear. We should see 2 of these when the page loads up. Yeah, we do 2. And then when I click these like this through the whole optimistic cycle, except for it clearing on like deletion or something, you're not going to see any more to-dos. We're not rendering it again when I'm doing like these fine-grained updates. No one's suspecting that, but also when it's refreshing from the server, we're also not re-rendering again because of the data diffing. So like, and when I go like this, you know, I end up with 4. Oh, it's because of this failed add. It added it again. But like, I, you get what I'm saying. Even when it went from even when it went from impending adding to final addition, we didn't run it again. Except for this case where it errored. It's a slightly different case, um but like so there's obviously going to be a couple places, but like generally speaking, the component runs once even through the whole optimistic window. Yeah, so generally the approach I've taken here is the same. Like technically you could cancel your, how should I put it? You can write logic to cancel your stuff in flight or in the middle, but there's no reversion mechanism. We're working towards a single future. So like the look at the anatomy of an action. I guess it's the best way to look at this, right? To yeah, here. Like I'll just pick one. Like maybe this one's the best one. Remove 2. We're setting some kind of optimistic state. We're doing some async work, and then we're doing a refresh or another. It could be a set, like maybe you took the results and you set it. Then you're doing some reactive update. If something happens before this, canceling is fairly straightforward because there's like the cancellation will just cause the optimistic state to lift, right? When when this update is done, when this action is done. If 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 you if you're doing this, once you hand it off to the fetch side, like you're saying setting some state or doing some kind of refresh, if things fail on that side, the UI picks it up, like the error boundaries or whatnot. So like these are just two systems that really feed nicely into each other. If that makes sense. And I'm gonna pull up a picture to help visualize why this is important in a minute. But I'm I think I'm gonna move on from this for a second. I just want to show that async first, which is the idea of like kind of in Solid, this is actually kind of a blend of Svelte async APIs and React's async guarantees. We've kind of merged them into a single system, and that I believe is what true async first is, because Svelte has the API of it in the sense that like everything is async and it just kind of works, but it doesn't have the same guarantees as React. React has the right guarantees, but has to, because it has to deal with this, isn't going to just pull the rug on everyone. But the funny thing is they made really smart design decisions early on that almost align it perfectly anyways, but this is very hard to deal with. So why this is important, I'll get to in a second, but you can already see that we remove a whole class of issues structurally. By making it declarative, we basically made it like, we basically designed out the edge cases, right? Like, okay, let's continue. Sorry, I'm just gonna look at my notes here for a second. Okay, right. So that's async first. The other goal I said was isomorphic first. If we go back here, and what is isomorphic first? It's kind of like this pattern that we kind of started pushing with Solid Start and kind of got replicated into TanStack, and then Svelte kit started picking up a lot of the same primitives that we were using. So it's again kind of a similar vein, but the idea is this is just a double down on the SPA. Yeah, sorry. There is no distinction between what null undefined as a value and what simply not loaded in yet. That's another bug that you often find in classic async things. In this system, there is a differentiation. Null doesn't mean not loaded. Null means no value, because if not loaded, we throw. So there is, yeah, like, yeah. You can use a compile summary within. Let's see if you still think that after we finish where we're getting to. I think there's a lot of the conversation I had from the guy with Datastar was almost perfect, and I might be misreading what he said, but I started realizing that he basically wanted an example or some benchmark or something he could build with hypermedia, like HTMX type stuff, that would really show off convince the single page app people this was the way to go, because he doesn't just want to like he doesn't just want like people. It's not just the fact that he thinks that most apps don't need to be single page apps, which I could agree with him on. He thinks that single page apps don't have any reason to exist, like that the whole category, the whole type of approach to JavaScript has basically no value, and people should do that on native apps or mobile apps and not on the web. And the problem is, for the people who believe that, we actually have examples that don't make sense for him to do and he can't win at. So his only option is to say that this can't be a thing. And I mean, it's perfectly fine, and within his range of scope that makes sense. But that I think a lot of people who come up to me and are like, yeah, what about HTMX this? It's just like, I can show you something that doesn't make sense to do with HTMX. You can tell me that it's not important, or I'm doing the wrong thing, or we shouldn't look at the problem like that. But you still don't really solve it nicely with HTMX. You know what I mean? Like, if I think that it's important, if I think that is the shape of the problem, that our argument isn't going to get anywhere. And I think a lot of people taking the server first approach are just missing part of the picture. That's why you can have really great architects people really knowledgeable in these things say, basically make that claim and still be missing it. People phones reloading on pre, or they're yeah, I mean a little bit, yeah. Yeah, I know, I know. But yeah, I mean, but there are like things like Datastar that let you use signals along with hypermedia, so you could kind of like shift the balance, for something that's really client side a bit more to the signal side there. But um, I'm getting there. Just it's like almost exactly where I'm getting to now. So um, uh, the idea here was that we push so hard on server first, but mechanically, as much as we try and hide it, the mechanism is isomorphic. Like essentially, there's been this tension in the web since the beginning. There's a client and a server, and one perspective of single page apps is that that's where we're pretending that the client and server don't exist as separate things. We just want one app representation, right? And that's not a real reality. There is a server, there is a client, there's a network in between. This is not something that we can just pretend doesn't exist. But a different way to look at this, and a more mechanical way, is if you had the ideal system that handled all the scenarios, let's say one universal approach that handled all the scenarios, there's certain parts of that solution that exist in those different ranges. And it kind of just comes down to how you can, the ergonomics around actually wiring and piecing these pieces together. And sometimes when you force a certain abstraction for simplicity, you cut off parts of the picture. And like the one that gets me all the time, and I think this is the one that everyone feels about React server components generally when talking about Next.js. It doesn't have to be implicit in React server components completely, but where that feeling is, if you have client-side routing, like mechanically, what happens when you have a server component page, when you're actually routing page to page? Yes, it goes to the server to render the content, but the routing, the actual like way the rendering, everything slots in, is actually client managed, right? It's not just the pure browser managed. We're no longer saying, hey, browser, reload the page. We are taking control. When you try and make abstractions hide that away, and I'm not saying necessarily that Next does that, but I think that's kind of also tie on to stuff like HTMX perhaps, is that you start getting a fundamental misalignment in terms of like what the abstraction is versus not. Now, something like HTMX, for example, is perfectly consistent through the fact that we're just using hypermedia to swap out HTML panels. But it has no answer for shared state, for client state. It basically treats ephemeral state or client state as something that doesn't exist. Because to solve that, you would have to somehow get that state also on the server. Now, if you have WebSockets, if you have live view or something like that, you could argue that that is a perfectly consistent model that's server driven. Because of the persistent connection, you could keep all the state there and you can do that. But you still are dealing with something that is real, the network. The client interacts, it still has to get to the server. There's still there's still a layer that happens where you can do something on the client without the server. And without appreciating that, that's why the key kind of disjoint is, basically when I was talking to the Datastar guy, I was like, I gave him all examples that were optimistic update driven. And he was just like, I refuse to accept optimism as a real thing. And I'm like, okay, that's convenient for you, but think about offline first, or sync engines, or there's a reason the SPA reality is they've been optimizing for immediate reaction instead of viewing it just as like bad optimistic UI. Like think about things as like an eventual consistency standpoint. Like I understand distributed systems are hard. It's very easy to say like, well, the server is ultimately the source of truth, so we should just wait for it. But in practicality, all the work in the single page app world in the last few years is about immediacy in the client. I am not waiting for the server. So whether it's optimistic UI, sync engines, I mean, you could like any kind of mechanism that lets the client get ahead is basically the test, the benchmark. And if your system does not handle that or handle that ergonomically, then like you are missing part of the picture, right? Apps are multiplayer games. You know it's good when the release is about React. You, people need context. We wait till the conclusion. Okay, so my the isomorphic first framework, yeah, is kind of just aligning the mechanics with the reality here of what we're doing, right? I don't think there's much. This is important, but what it actually kind of revealed is something that we talked about a bit about on stream, and this does to your point. That's the difference between a web page and a web app. But I think there's a more general truth, and this is one I think architects can appreciate. I had this on my screen most of a good chunk of last stream, and I realized that these are three really real realities when you start viewing the world as being derived, and this is tying in to to all the stuff we've been showing. There's a reason the solid to dos example is simpler. There's a reason that the even the multi-click one was simpler in these examples is instead of using effects to write to state, instead of doing all these imperative state updates where we're tracking all these things, we made everything essentially derived. And so why is this out of, sorry, I put a console log in there. And like it's funny, it's literally this little one like 2-line function. It's like get the to-do server source, apply errors, error overlay, and then this creates the set to-dos here, which is the optimistic overlay that we apply on. But it's a derived overridable system, right? And this drawing is actually the whole scope of front-end development. Like this is the universal thing. And maybe, classically, front-end frameworks live here, right? Like this is where the front-end thing, state management. I called it mutation, but this is React, right? This thing here. This is where we live. This is, front JS framework, right? This is the classic space. I mean, I don't know. It's hard to just pigeonhole React simply in here, but whatever. I don't know if I want to make this visual, but JS framework. Okay, let's just put this in here. This is classically where we've sat. This is where we came in. We lived in a world where you had a server and you had to, I said refresh, but it's more like reload. Like it's refresh, reload. You get the idea. So initially, our JS frameworks have basically sat completely in this layer. We treated the server as someone else's business, right? Just a view layer, whatever. We realized it wasn't just a view; it's actually a view and a ephemeral data model, which is why we have components, not just MVC on the client. But the model, not the view model, and not the view, not the component. We knew it was somewhere here, but we didn't really care to define it. Obviously, when we added SSR, we branched out this way, right? But when you talk about something like pure HTMX, it's basically only concerned with this zone, right? Right? It's concerned with how it does its reloading. It has granular reloading because it doesn't require reloading the whole page. but it's over here, right? This is what it's concerned with, right? HTMX or whatever. Like this doesn't have to be a full page reload. Maybe I'll continue using the term refresh, but this is the mechanisms it has working for it, right? I'm on Twitch. I'm always on Twitch at Ryan Solid. And I'm also on X, yeah. And we got the Twitch link. Sorry, let me drop that in. Sorry. I used to post something on X that was like, now I am live on Twitch, but then I stopped doing that because Twitch X had its own mechanism, right? Here's Twitch. All right. So yes, and there's a comment here that data star is kind of like both or isomorphic, right? And it kind of is. This is not a pure range. It's just I want you to understand, like, because in a sense, when we add when we control the server functions or the server components or whatever, like the APIs and stuff, we're taking on this responsibility. I'm just talking about traditional responsibility. But this layer also kind of sits on the client. But most solutions never had us like recognized that this was an actual thing, so to speak, right? Like it's hard because when you have just the two of these, you don't really need to think about these in terms of derivation or data flow. Like you can just be like, oh, I have an app that does these things and just syncs up with the server. You don't view it as part of the same system. But once you're looking at this end to end, you kind of have to. And what's interesting about this is previously this layer was not very easy from like to represent, because these each have their own life cycle, right? The request, the client side ephemeral state, like how long the component's mounted, and this one is actually so ephemeral. It's not even the UI, like, so this one's like, let's say request scoped. This one is what are we gonna say? This one is component lifecycle. This one to call interact through transition. I almost want to call it an action these days. It doesn't really matter. Actions in our definition aren't this, but I don't have a good term for this. Anyways, my point is this one is scoped to like, it's scoped to the action though. I like, I mean, like a user action conceptually. Call it transition, but it's like range of time, right? This one has, you can say this one's a range of time as well, but like there's a definite life cycle consideration here. And when you try and mix life cycles, things get messy. And we need a way of communicating or being able to do this kind of split. And this is why this example really resonated with me when I was talking about this example. And even the React implementation ended up layering it on as errors, which I don't know if that's how we would do it. I'm trying to think back to the Remix Trellix demo. And the Remix Trellix demo they basically layered on the mutations and the errors in the same thing. See, and I think this is where the fundamental split happens. The Remix treated optimistics. They treated both the optimistic state and the errors, like because they're part of the submission, part of the action, as the same kind of thing. It's a reasonable thing. You have the server data, and then you have this layer on top. I realized that these are actually two separate things. The optimism is the time-based thing, and it was always hard to know when to clear the errors. It's because the errors are not tied to the optimistic state. The errors are something that actually persist and live within the lifecycle of the component. So this is why this split is so easy, because server truth, client level, which is actually like, where I'm getting my errors from. I called it mutation, but essentially the client level are things that kind of live within the component lifecycle. Like when I click add to do, I remove it. It's something that's like part of the kind of UI lifecycle, the state of being errored. And then the ephemeral, which is, where this optimistic state lives. This goes away whether it's errored or not. But because we have this data diffing engine that can kind of apply these together in layers through optimistic store, we don't lose references, we don't cause re-renders, we keep things fine-grained and update. Some people compare this to a sync engine, and they're not wrong. The UI layer feels like a sync engine, even though the backend, this part doesn't care about what the transport engine is. And it's because of the fact that we can have these things exist together as separate layers, but then be reconciled together. And going back to our drawing here, it gives clear separation. Like errors actually belong here in the client overlay because they persist past the range of time, right? It could also be success messages. If you had success messages, they would end up here as well because they have their own, their time is managed. They're not connected to a specific window. I hope this makes sense. Go up to the duration of the state update. Yes. But I mean, it's scope to the range of action state update. It's the reason we use generator functions actually, because we have to tie these things together. If we didn't tie these together, you'd get those race cases that we saw in that other example. This is why it's yielding and refreshing in the same kind of pocket of time. It's because we need to say that this optimistic lasts not just while we do remove the to do, but also until we know what the stable state is, until we've actually done the state change too. Because if you don't do that and things overlap, you're going to be managing craziness. So, okay, let's continue. I think. So once you start understanding the characteristics here, you start seeing that you basically structurally remove a class of edge cases by being async. You've created a home for a whole different category of statefulness that can manage its own life cycles in a consistent manner. You start understanding why this whole model kind of just collapses together, right? And it's based on these async first and isomorphic first principles. They just feed right into the exact same model. And I threw something together, or AI helped me throw something together, and I'm going to run this past you all while we kind of just look at this. I think, did I share it? I did. Copy share link, I'll post it. This is very rough. Like this is why I'm not publishing as an article right now. I want you to understand. I want you to put all the pieces together to understand what this actually means and what this means for AI. Okay. The era of coding is being replaced by the era of system orchestration. As AI agents flood our repositories with imperative fixes for async problems, the architecture's primary challenge has shifted. You're no longer managing a team's output, you're managing complexity depth. I know AI writing stuff is always, in a world where AI can generate infinite working code, the framework you choose is your only defense against technical entropic collapse. So one, beyond the loading Boolean. In traditional frameworks, loading is treated as orphan state, a manual Boolean loosely pinky promise to sync with a signal. This is a structural flaw. It creates a gap where UI and data desynchronize, leading to the race conditions of flickering that define modern web dev. So, Solid 2 standard. We've moved the async logic from implementation layer to a reactive runtime. We treat all state not as a static point of time, but a temporal tuple, a now and future value, right? When you say latest something, you're asking about the future value versus the current value. Everything is, when you talk about optimistic data, you're talking about the future value versus the current value. Basically, we've modeled time into a tuple, essentially, two values. And this is incredibly powerful. As you saw, it simplified these issues. I remember when I watched the Remix 3 review or unveil, and he did that drop down, and he's like, don't you just want to say, loading true, fetch, use my async abort controller, and then loading false, and just call it a day, right? Ryan's incredibly poignant at pointing out people's pain points, because the challenge we've had with React was this challenge. We did a whole bunch of state stuff that's supposed to protect ourselves. We've structured everything properly, and we still introduced all these bugs. It's like, oh, we need a abort controller. Oh, we're missing our cleanups. Oh, we have in-flight stuff that canceled. And no one feels this more than the Remix team, who basically built Remix on this React. They didn't have like modern suspense. They didn't have views. They didn't have any of the, stuff that React's been adding React 19. They took this React and tried to make something, that gave people the guarantees they want, to the point that they got so frustrated. They're like, we're going to just do this ourselves. This complexity is us. They felt like they're fighting it. Like, it's like, why is there a use callback all over? Like, what is even going? Yeah, sorry. I mean, this is an action, I guess, so they can use callback. But I think they started seeing React APIs pop up in places that just didn't make sense to them. So they're like, screw DSLs. Let's just give you naked vanilla code that any AI can generate, and it can have at it. And then you just kind of wire it in as simply as possible, call update yourself, call it a day. And I found that argument compelling initially, but as I started coming around on it, my perspective at least is that is the exact opposite way things should go. Because you're not actually solving the problem. You're just taking us back to a state where we didn't have abstractions that got in our way, which is a good thing. But you have to, when you step back, you have to be able to step forward. This tuple approach makes a lot of sense to you? Good. So I'm calling it out right now. This is a big deal. You see hints of this everywhere. Let me mention good old David Corsid, XState. He is so against like the Boolean craziness, right? Like he's done conference talks on like practically, I feel like, on why Booleans are terrible. But it's not just that. It's state. It's using, like he's like, look, most things aren't Booleans. They're enumerations, but you can still have combinatorics of enumerations that don't make sense. The actual problem is, in order to model something that is just outside of your range of easy modeling, you usually have to create abstractions using the building blocks you have. It's not your fault. It's just these are the building blocks you have. So like if you don't have the right primitives to describe the problem, you're going to use a whole bunch of other primitives to try and make up for it. In the case, you're going to be like, okay, I'm going to need an effect, and I need all these states to manage the temporal state of the loading, and also the pending state, and also the concurrent state handling, and the forking of visible versus not visible values. Like there's a whole category classes of these things that now suddenly will leak into your state when you don't have the right model to represent it. Okay. So number 2, determination by construction. Architects know that the gap between an action and a resolution is where the bugs live. If AI writes an effect to bridge the gap, it is a coin toss whether it handles cleanup or race conditions. Solid 2.0 standard. By treating the feature as a first-class citizen, the signal itself, we eliminate manual orchestration. You don't handle a promise. You define a topology where the UI is a perfect reflection of the value's timeline. What made signals so powerful were that they were a single point in time, right? You can be like, look, this is a snapshot. Now, by adding this extra dimension in terms of like now and future, we've basically applied the same solution to time. Right. Right. It turns into a structural impossibility, right? We've turned the most common UI failure into a structural possibility. You don't get like when you like we kind of joke about how we solved waterfalls. Like, no, there's still possibility for waterfalls and data waterfalls, but it's not going to be caused by the structure of UI code. It's by your actual data connections. Like, there's a whole classes of things that just drop off the end when you don't give people the approach. Now, you could say this is very limiting, perhaps, but it's also just aligning the model to where the reality is, which is something I feel like we have the ability to do. The reason we have the ability to is because we've been very fortunate with Solid. Solid 1.0, we got a lot of things really, really good right. Like, it's the reason why we haven't had to change it in 7 years, really. Like, it's worked. We did not get the async story completely right, but everything else has been good. So been pretty good. There's been a few little things. The point that most of the stuff is cosmetic that I need to address with Solid 2.0. Like, that's why there's some renaming stuff and like a few little pieces there. There's a few key behavioral things, but it's important to understand that because we had the right abstraction with signals, we had the right right way to like model the application, even though this is like a significant change. In the actual feel a lot to the majority case of users coming in here, it's just going to feel like Solid 1.0 still. Like, it doesn't feel like the huge breaking change, because we didn't have to shift very far to get here. We were already doing the right things. Whereas I think a lot of other frameworks, in order to get here, they actually had to like shift to say like what Solid's doing and then shift again. So like this is why I wanted to spend a little bit more time here, because I feel like this is going to set us up for the next 10 years in the same way we've been set up for the past 10 years. I didn't show this on here, but the funniest thing about looking at this table is just how old the JS frameworks are. People don't like, and this is publishing time. I wrote Solid more like 10 years ago, but more than that, like over 10 years ago. But the thing is, the newest framework on this list that we're doing here is actually SolidJS, and that's 8 years ago. These are not new tools anymore. Svelte 9 years ago, Preact, Angular Core 10 years ago. So this is like when they switched to Angular 2. This is Preact. The oldest framework on here is actually React, and then Vue. And I think the age I think this is a fairly accurate showing of age, on where these things are. It's kind of funny because it makes Angular look newer, but to be fair, Angular 2 was like a different framework. So yeah, this is a long time coming. Okay, let's keep on going. Guarding the main thread against AI slop. This is where it starts getting interesting. AI favors a path of least resistance. In virtual DOM frameworks, this results in heavy re-renders and efficient hook chains where humans eventually lose the ability to debug. Solid 2 standard. Our fine-grained reactivity is the only architecture capable of absorbing the volume of code generated by autonomous agents. By providing a transparent runtime, we ensure that even unoptimized AI output runs with surgical precision. The code remains a readable graph, not a black box of side effects. Right, because once you turn this into a directed problem, graph problem, once you turn this into being a derived problem, like, it's what I was trying to show in the other example. Like, I could have got to it with the exact example too, but it also, then I'd have to add a bunch of code to actually optimize the specific rendering. Solid, when you wire it right, is optimal. So like, the as long as we give primitives that give the way to represent the problem and basically put the orchestration in the background in terms of how to manage this, it keeps things very modular. So you can have AI working on these different parts together in a system, right? This is something that React realized with its component model, but our rendering continues this pattern all the way down, right? So stability is a feature. Stop chasing ephemeral features and start building on foundations. Solid 2.0 is designed with long-term stability of the web, focusing on pure computational primitives that act as a permanent bridge between your logic and the screen. We don't want to help you write code faster. We want to ensure that the code you write or the code your AI generates is correct by default. That's the pitch. And I think when you view that angle, this makes Solid also an AI first framework. As I said, I wouldn't have considered myself an expert enough to make this classification previously, because I didn't use AI enough. But what I've seen in a very short time suggests to me that all these characteristics that basically what I call this is temporal determinism. Sorry, I'm terrible at naming sometimes. Is is all of these elements basically streamline the the architectural constraints here in such a way that we abstract away the hard problems. All that's left is describing the intent. And I think this is the whole like language parity kind of question. This is what makes Solid 2.0 interesting, and like a big deal, because by baking the async semantics into the reactor graph, by making it part of the system, we have basically solved all three of the directional goals in one burst. We've solved async. We've given us a way to understand the modeling of client versus server versus clients versus ephemeral. Like essentially, we now have a model that's consistent through this range. We can't be like, and like works well. I think this is the gap, that this is what we're like, what spas and everyone are chasing right now, you know? And, you know, why I'm very interested in stuff like local first. And importantly, this makes sense for AI. It makes sense for systems that basically need to generate your code and amalgamate it together. It makes sense for you now. I talked about this the other day, where I said that, actually, no, let's pull this tweet out while we're here. Yes. Yeah, that's my data star conversation. Let's go to my profile. I was talking about this the other day. The next 2 years are interesting. Despite the popular belief that the world's going to slop, things like this tend to do the opposite. We've been blessed working as software to have one of the greatest professions. We can take an idea all the way to product, distribute it to users without leaving our desk. And while when scaling this up, we can benefit from specialization, we haven't always needed it, which is a key point, right? Most other fields had historically craftsmen, people who are experts. You know, engineer might design something, but they're not going to like pick up the welder, so to speak. Like we had professionals do this. Where in software, we just did the whole thing ourselves, right? We were the visionary, designer, artisan, salesperson all in one go. I think AI paints a pretty clear picture. Software engineering is finally going to resemble other engineering disciplines. The skills and expertise need to fall more in line. This is a huge switch. It changes the way we teach, it changes the way we hire, and it changes the skills we value and how we measure success. It shines light on long-held misalignments. Success by lines of code is like operation in an industrial revolution if they measured it by like the size of their electricity bills. The profession isn't going anywhere, but if your current job is equivalent to, I said basket weaving, but honestly, it impacts the craftsman somewhat too. You might need to examine where you stand. And I think this is part of this, because Solid's always been a framework that appealed to the architect, right? It's not, it has a certain elegance in design. It has a certain transparency. It gives you control, and it gives, you know, it gives you this incredible amount of power, which in some cases can be wielded in ways that, you know, maybe aren't good. But on the other hand, it is structured enough to give you the guarantees that make you feel confident, right? Like the glitch-free propagation, all these things. These are things that make you feel confident that you are building, you know, sorry, the pun, a solid product. And in that age where we're going, if you believe along with what I'm saying here, and if you look at the constructs and stuff we're doing here for engineering, we're the logical choice. Like we are in the exact spot that we are meant to be as a solution. Solid is designed to cater to you. And I'm not just talking about the people on this watching the stream. I mean, it's literally designed to cater to the future engineer who starts up a product. People talk about, oh, I'm worried about this, you know, React and onboarding new people and all this stuff. the way you're onboarding new people is already changing. This is why college grads have been having a hard time at first. I think that's going to change really quickly because college grads are fresh clay. I think there's a lot of potential here of people realizing that the actual problem is not them. We bring them in, teach them the way they need to be taught. It's going to take some changes on like, your level sixes or level sevens or, like high level engineers, specialists, ICs, you know, like on that end a bit on how we interact. But we have to actually change the structure of how we do software engineering organization. And I, I feel that SolidJS is perfectly aligned with your goals and the future here because by design, we literally help with that problem. Let's see what chat says. Yeah, I did coin fine-grained reactivity. Yeah, it's fair enough. Maybe some of my stuff hangs. I actually saw something recently. AI. What was it called? What did I call it? Async first. I think I coined that one. Um, Although there's a different async first manifesto, which is not what I'm talking about. What was this one? Yeah, this has got to do with agile. But yeah, I'm not going to find it. But I actually saw other prominent people in the ecosystem like do podcasts actually using the term. So I guess maybe the coins, maybe that's not the worst. My calling influence loose includes modeling. Reading article here is exactly what I've chosen effect to. Trying to give elements the only right thing to do. Effect is great, and I think there's a real natural fit between solids. I mean, I haven't confirmed this, but my gut is between solids action API and effect are going to be very, very good friends. I think that our general process for describing UI, like the get side, is beautiful, and I think the way we incorporate async into the channels thing, where all the complexity is going to lie now. Once you make this beautiful projection of your data through your UI, is going to be in your event handlers, in your effects. So like that's where the mess lives. Effect seems like a good tool to wrangle in, and I think my hope, and I'm going to look into this a bit more when I get a chance to look at effect. But my gut is effect and solid actions are going to be like bam, like this is part of that same narrative. Right. It's cool. It helped you rapid prototype and so you're not just stuck in the thinking space too long. Yeah, it did. It did help me a lot because I get stuck on thinking, not because, um, not just because like I'm overthinking things, which I mean I tend to do, but because I recognize my lack of resources. So I've realized that a little extra thought ahead of time saves me a lot of time. Like it was absolutely essential while I was building Solid 2.0 to think a lot because if I was just like, okay, I'm just going to do that, I could waste days, weeks doing the debugging, going through the whole cycle, and then being like, yeah, actually this doesn't work, and I just wasted 2 weeks. So yes, very much so. Yeah, greenfield problems are not a problem. They can avoid adopting brownfield projects. 10 years cannot afford it. Well, the funny thing is, AI might change that math. A house for an architect is a house for only one person. It's true, or a small number of people, and but I think you're gonna like that's where the engineering field is heading. You're gonna have like don't get me wrong. The capability of the average person or is gonna because of AI just being able to like the thing I didn't say in that post was because of AI being able to just like let you go generate an app, do this like vibe code and get easier and easier and easier. The capability that the average person will be able to do, or even like the slightly technical now, is going to extend incredibly. Right? It's democratizes it, makes it accessible for everyone. There's still going to be experts. I think we're seeing a case where specialization actually starts mattering more, where it hasn't previously. It's long TypeScript giving confidence. Yeah. I haven't looked at effect enough to know what the impact of it. I think part of it is understanding that some code, like we love declarative code from the perspective of like, like with UI because it's the best representation and where most things should live when we're designing user interfaces. We want the synchronization. We don't want to think about how synchronization works. But like RxJS or like a few other things, there's a zone that is events. There's a zone where there is a sequence, right? And now in Solid, that's very well defined inside of the action primitive. That's where the sequences belong. And I feel like maybe effect is a better way of describing that. I don't know effect enough to know that though. Right. Parent COBOL can use convert COBOL. Sorry, AI can use convert COBOL. I believe it when I see it. Yeah, I mean, yeah, it's. I mean, the beta fixes all your external problems. Great, because we're almost this. Brenly is my secret ninja. I mean, not so secret. I think he's kind of well known in our communities for posting all those great like how to get started with solid articles and like wrap your mind around like the mindset. But he's been like testing and implementing stuff with the beta. When I was talking earlier about solid start and TanStack start, like basically already working on the beta somewhat. This is his doing. So this makes me very happy and confident to continue on the stream, knowing that the release I did at the beginning of the stream apparently is in a pretty good shape. Okay, so I've already spent almost 2 hours on it. That's longer than I was hoping to, because I want to get into breaking stuff, obviously. But I think, and as I said, people might disagree, but I think this is a big deal. I need to tighten up the messaging. I need to get here sooner. I need to figure out how to communicate this to people better. That's why I tested on people on the stream, so to speak. But when people talk about, oh, React has the bigger training models and all that, I just think about this, right? This is what comes to my mind. React knows it has to change, and it has been changing. So we can't stick our stock in this in the past. It just the future for me at least is clearly here. Whether other things are manifested alongside this, sure, but this has a lot of inevitability to it. I like you mentioning COBOL. Just on a side note, COBOL is like the perfect example of like of of the thinking that AI almost closes the loop on now, right? Because COBOL, if for those who aren't familiar, is an like old programming language that they tried to use English to program, which, as you imagine, is clunky, doesn't work very well. But you get the intention. They thought, well, how do we make programming more accessible? Let's make it less mathy. Let's make it feel like English, like you're just talking to the computer in a conversation. I'm pretty sure that's how they sold it. And ironically, now we can. So it's funny to see that go full circle. Yeah, sorry, 2 hours my memory supposed to be loaded to mirror error. It's kind of yeah. The Arid is my least favorite. I have to admit. If you guys can come up with a good name there, I'd be pretty stoked. Loading is what I wanted it to be, and I wanted like loaded. Um, loaded isn't quite right. I like the verb. I like the present tense, not the past tense. It's just errored is I had no choice. Do you really want to type that? I'm just I want to I've been trying to get away from some of the language here. I don't want to use the term transition anymore, and I was hoping to get away from the term boundary. Catch, but what are you catching? The funny thing is we actually did this bike shedding already, like in the Discord channel. Uh, So I mean, yeah, we got some RFCs up there. The funny thing is, you guys might have thought I'd go through the RFCs on stream. I went through the RFCs on my last stream in detail. I don't think anyone's paying attention. No one was talking to me about it, but I literally reviewed all the RFCs on my last stream last Friday. So like, but I want to get into some real code. They are the most self-documenting. It's true. I was just hoping that we could. Sometimes the most self-documenting name is like Microsoft API names, and it's like it's tricky to, you can go too far down that line. There are two hard problems in programming. Ryan spent previous talking about async, which is problem number one. Now we're talking about naming, which is number two. Okay, let's keep on going. Yeah, let's move the conversation forward. I hope this is at least more clear to you now that the pieces together paint a complete picture. This is not just about async first. It's not just about some specific feature that we're doing. It's like, oh, can Solid do blank at this? Because then you're just back to the checklist. It's about presenting a model that, by its very nature, gives confidence. So what's the best thing to do when you have a model that gives confidence? Let's try and break it, right? Like this is why I went this way with the stream, because I part of it is I think there's bugs. I know there's bugs, and I want to find some of them. Second reason is I built so many primitives. You know how we were talking earlier in the stream, how like no one knows about Solid working on other platforms, or like all the features we have. Solid 2.0 is like that too, because in a sense, the primitives are so powerful. And even though I've streamlined them, there's actually less primitives now than 1.0 in the core. The overlap or interception of the primitives together create emergent patterns that even I can't foresee the outcome of all of them. Like it's like these things work together really well, or they should work really well, but they can take us to places that we've never been before. I don't even know where they're going to take us. So I had a few ideas of things I wanted to try to kind of play around with that, and to kind of help do that. What do I want to call this one? React to do's buggy affordances. Call that. Keep that demo for later. I saw vacancies for SolidJS for hotel reservations that work on TV. Yeah, Lightning JS is actually a big deal. Comcast, Xfinity, like Peacock, Universal, and like all that stuff. They use Solid a decent amount on their television apps. So I'm actually, now the beta's out, I'm actually really looking for feedback from those guys. I know Chris is on it, and I'm hoping others. So like, I would have engaged them earlier, but I really want to nail the reactive system. Okay, so what's our setup here? Did I break something? No, this looks good. Okay, what's our setup going to be for this? Well, I did a couple things. I'm going to share these on stream because you guys probably would appreciate them. I made 2 templates essentially on Stackblitz. I should update them now that I know that we have, is next to the latest? I think so. We have beta 1 out, so let's update these. I tried to just take the stock Stackblitz template, and all right, hopefully that does it. And this is, I beat an HMR working again. Now, this is solid HMR. This is not, like when I do this, you're gonna see the circle start spinning. I have not solved the fundamental state preservation thing. I don't know if I'm going to solve that anytime soon. We have some tricks around it, but I'm not, but we have HMR, which we haven't had until now. So right off the bat, awesome. I'm going to drop this template in the chat in case anyone wants to build some solid 2.0 stuff. This is a good starting point. Oh yeah, Bell 5. Yeah, there you go. The TV app for Bell in Canada also uses Solid. TV apps. To be fair, Netflix really wanted to use us. Like really, really wanted to use us. They were trying almost anything to do it, but ultimately they decided at the time that it was too expensive to migrate the code. Because you know you're in trouble when someone reaches out and is like, "Can we like turn off the untrack on the top level of components?" And you're like, "No," but because they're like, then our stuff basically works, and it's like, yeah, not the way you think it's working. Okay, so first thing that I want to talk about in terms of breaking Solid 2.0 and is I actually want to play around a bit in here and let's fork this. I don't really care about the logo or any of those things. I actually don't even care about the styles. I'm going to treat this like a dumb playground. Okay, we have a div. And in our div, we say hello. Okay? Perfect. Okay. Sweet. Let's continue. Okay. So, let's do some basic stuff here. And I want to see how this plays out because I haven't tried the latest with this, but let's do something that let's make a counter component. Should we do a counter component? I don't even know. Maybe we should just make a button component. I don't really care. Let's make a button component. Return button. And what do we want to do? We want to do like on. Let's do something here. What does our button component have? It has on click. I mean, I suppose I could spread it, but I'm gonna do this. I'm gonna do this on purpose. I'll click, and then children, I guess. Do some children here. And I think that's probably fine, right? And then we'll make some state here. We can do like const count, set count. Let's create signal 0. And then we can maybe use our button and show count. Count, yeah. Sorry, I don't have any linters or anything set up, so I might not be able to see any mistakes I'm making while writing this code. Oh. Yeah, I guess whatever, it's just a TypeScript error. We don't care. Let's go on, click. We should do on click, we should go set count +1, probably. Sweet. Oh man, my counter is not updating. Why is my counter not updating? We're gonna break it in lots of different ways, or try to. Well, I just broke. Damn it! I broke Solid 2.0 already. Broke it already. Counter doesn't work. See, this is. Are we not on a dev build? I was like doing all this setup just so that I could do this. Are we? Is this not on a dev build? Oh man, why is this not on a dev build? This makes me sad. This is like this defeated the whole purpose of what I was trying to show. Why is this not? Are we not on it? I want to see something. Let's. Oh, we just broke solid in a way that I wasn't intending to break solid. Why is this not doing this? Let's look at I just want to sanity check here that we're on the right. What are you doing? It's like really annoying when I'm trying to like show off the screen. What am I looking for? Actually, it's probably this chunk that I'm looking for. Actually, recompute can work. It's like so annoyingly narrow. It's because I have my screen blown up so I can show it on the stream. Recompute, where are we? I just want to see something really quickly. No, it is there. What the hell is going on? No, this is supposed to tell you that you can't destructure props. That's why I was like, what, like, do we have am I hiding something here? This should, this, yeah, I'm actually really disappointed that this is not showing the error. Because, I mean, let's try getting to it more directly. Props.children. Right, because that's sad. This is what happens when you don't have a chance to test this stuff in these environments before you do it. So annoying. All right. Well, so much for the first part of this. One thing that we added in 2.0 is more guardrails. So like this is supposed to error. I mean, we could try and trace why it doesn't error, but essentially, I mean, okay, let's see if we get there. There's only one reactive read in this whole thing, right? So if we go to read the read function, we should be able to see this check happening in real time. Not that one. This is a bad check, just on a side note. But we should be able to get here. What are we reading right now? I'm sorry to use this as a debug session here for a second, but this is part of what's going on. What are we reading? We are reading computation, it looks like. What value is a function? Okay, this is got to be like... Okay, let's try the next one. Makes me want to go back and fix it so badly. Yeah, these are the dev components. I wonder if the dev components are actually getting in the way and we didn't realize, or I didn't realize, because it never gets to here with. If we go edit breakpoint strict read, so like it's true. I don't think I ever get here because something's like, yeah. This was a fix that I did in literally beta 1. This actually works in beta 0, ironically. I'm gonna sanity check this just because it's bugging me, but no, it's just broken. Lovely. Yeah, I think my guess is what's happening is that the check is getting overridden by the dev components. And because in the solid environment we like don't have HMR and like the dev components, that it's actually messing with it. Okay. Well, good to know. That's a bug for me to fix. The what we should be seeing, so that did not take us long to break solid 2.0. Sweet. What we should be seeing here is that and I'm gonna go back to 1. What we should be seeing here is that depth solid chunk. This lovely message. Reactive value read at top level of component name. So it would say top level of button. Will not update. Move it into a tracking scope like JSX computations or effects. That's what should be happening here. Basically, we now have a runtime warning when people destructure props or try and like, use stuff at the top of the component or at the top of control flow without actually like wrapping it in a function or wrapping it in some computed value. Old team at Apple using it. Yeah, solid no public facing app like Apple Music though, yeah. Linter is good. Linter is not perfect. Linter also over reports. Like it'll catch destructuring, but there's a chance that it will also over report. I wanted to make sure that there was a mechanism that would actually hit you at runtime as well. This is dev only. Yeah, that's why I thought I wasn't on the dev build initially. Um, okay, so let's move on. I thought it would be a good opportunity to show people so I fixed my problem. I now am accessing it inside the JSX, and now our counter works. Okay. What is it? I forget the component type. There's a type with children, isn't there? Component with children. I can't remember. Whatever. Um, Children, JSX, element, whatever. Type JSX, whatever. Okay. TypeScript, be quiet. Now, there's another one that I want to show off. Again, I don't know why anyone would ever do this, but I'm gonna make. So funny. It feels harder to make this example than it is to actually do it the right way. But let's do this. Let's create a signal for double. We'll call it 0, and let's, for some unknown reason to me, let's create a memo that set double to count times 2. And then we're going to show count and double. Maybe we'll put a space between them. There we go. Hopefully. Okay. Yay. Okay. That works. But it kind of isn't great. So we actually have a warning here. Signals written to in a known scope. You shouldn't be writing to signals inside computations. See? So again, this is a dev warning, but this is another important key piece. Some people accidentally create like weird side effects inside their tracking scopes, like they'll call signals and stuff. Now they will know. So these are the two like main kind of guardrails that we have going on. It's hard for a linter, especially if this is abstracted into like another function, like someone did something over here, like function update. Actually, I'm not going to pull it all the way out, but because I want to reference, but let's say someone did something silly like function update double and value number, and then like did something like set double v, right? And then they're like if someone like did some level of indirection, you want to make sure that you're still catching this, right? Like what if they yeah, there is a certain amount of colocality of like the setter not being this is like one of the reasons I love read-write segregation, because like I can't just like put this here without passing the setter through. Like there's a certain amount of control. Like if this was like a framework that didn't do that, someone could easily like just be like oh, log double, and then like do something like, you know, v dot value, you know, like plus plus or something, you know. And this have no connectivity to where the stuff is. Like you know, like say console log something but increment something. The caller here who called the innocuous looking log double, you know, and like, I mean, I'm just making a different example now, but pretend that like we use dot value instead of functions for some stupid reason. Now, like they could be writing some actual derived state, like const, you know, something, right? Doing something completely normal looking, and then someone introduces some kind of garbage inside a function that gets shared that just happens to be called under this scope that mutates the value that was passed into it. And like there's just all sorts of bad that happen from this. Is the runtime warning completely necessary? Maybe not, but like because of the scoping means you can actually always see where the set double is. But you know, more guardrails are helpful for people, I find, and it costs us basically nothing. It does. The reason is, and I went over this on a stream and I don't want to recap it for everyone again, is although I think I wrote it up as a hack MD, so I can share it again if people care, is that there's a reason that you don't want this kind of write happening, but there is um, there are there are certain places where is it ever safe to write a signal in a derived computation? There we go. Good side reading for people. Basically, there are places where it's safe, but most of the time we want to force it into a constrained pattern like firewalls. Like in order to get projections to work, which are derived stores, we had to make it consistent, and in order to do that we had to make a mechanism that ensured consistency through state writes, because basically projections are an example of where you write to signals inside a computation, like that is the scenario. But I also recognize that cases like for or map array are actually micro projections. They're just ultra optimized. Instead of using proxies, they're designed to be like very to the point using manual signals, and it's like special cased. And if as long as you can keep the certain guarantees, like the shape of the problem, you can technically do it. So technically there is an override here. Like Solid has a lot of like yeah, okay, you can do it. Things like calling untrack will make it so that the like if you that top level thing that I showed a moment ago about how you shouldn't be reading top level, if you explicitly call on track on it, we're going to say, okay, I guess that's your intention, you're trying to have it not update, right? I don't want to advertise that because like 90% of the time, that's 95% of the time that's not the case. So if I put in the error like, oh, just call on track, people just call on track instead of actually putting it in the JSX, which is what they're supposed to be doing, or putting it in the reactive expressions. But similarly for the pure write, there is an option to say like, yeah, look, I know what I'm doing. Pure write, shut up. Like don't warn me about this. Don't there is a scenario, and if you care, here's a document to explain how consistency works and what those actual scenarios are. Right? Yeah. So I covered this on a stream previously, but it's very technical. The good part for developers is a combination of the tuple design and causing read-write segregation, and this warning means that it's very difficult to introduce weird inconsistency stuff by just doing that. Now, you might be like, but I want to write from state, and be like, and honestly, I get you, but I really, really want to discourage you from just like, there's lots of things like you're like, oh, I have a prop that I care about. Like pretend if you want the button was the one doing the doubling. You're like, I've got this prop, right? Um, this isn't a good example. I think of an example. The most common case is like when you have internal state where you're like, I'm going to maintain my own state, but I want it to be resettable by the parent, like in a form. And in those cases, you like, I need the synchronized state. And the solution to that is I'm like, why am I not relying on my demos? I have a demo for everything. Funniest thing is Ryan Florence's has historically made some of the best benchmarks and demos ever. His natural feeling of the pain that developers feel is really good source of finding good demos. I'm looking for states. Okay, perfect. This is a good example of this, right? Because this uses some async. The fact that it's async doesn't matter here. You can pretend that you don't like the fact that this is calling get states as async, and get cities as async doesn't really matter for what I'm about to show you. But if you need to synchronize, like you got some data and you're like, okay, but I have a selected state, so I want it so that when I change here, we select the first thing. Like this is state synchronization in a classic case where you like, if you're using use effect or something, you would like do the fetching and then you'd set multiple things in that location, and it might trigger if it's cascading again, set other things. But the answer most of the time is just derive it. You know, you can, this is a signal that's derived. So whenever states change its source, it will select the first one automatically. But you can also override it temporarily. So if you have props coming from the parent, just derive a signal from it. The answer usually is not untracked. You know, like I think where people are naturally gonna like hit this kind of thing is like they built their component and they're like, okay, I have state in here. So they're like, okay, I have const because they update it locally, so they have some value, right? And they're like value, set value, and they're like, okay, create signal, and they're gonna be like props.value, and they're gonna read this, and right now this is not erroring the way it's supposed to, but right now they'll get that warning that says you're reading this at a top level thing, and they're like, oh, what? Like they'll get that warning and be like, what? And if they're like, okay, fine, I'll untrack it, right? But the actual answer is most of the time you actually just want to do this. You actually just say, look, this is based on this parent value. When it updates, reset my state, and I'll override my own state. That's basically it. And I mean, this source could be props. The source could be, as I'm showing in this other example, it could be the server, right? If you view everything as a derived world, then you know, you can just go from there. You can just this whole system is designed to build overlays, whether they're optimistic, whether they're mutation based. We're essentially recognizing that all UI is derived from data and data derived from other data, and almost all representation is just the application of overlays over that, right? That the data, the server is the source. We even have sources entwined, right? Because when you change this, it has to get the cities, which is a different source, right? So states is a source, cities is a source. They wire together, dependent graph. But the key here is we didn't need any effects to synchronize anything, right? Now, what is true here is effects are still important, special, whatnot, because if I kind of go back from this and get back to our example, let's say I really need to do this. Like I have this crazy need to do this. Well, let's say you're like, okay, no, I need to do this. I'm going to create effect. Ooh, right. But let's pretend you do this. Now, in old Solid, you would just do this and be like, all right, I'm good. Well, this one's going to type error because this is not what an effect does. And in fact, I don't even know if this doesn't even, yeah, this it's not good. Okay. So you find out effects are splits. So what you do is you add a second function here, right? And when you click the button, it works. But that's not good either. A signal is written to in a known scope. Still complaining at you, as it should, because you are calling it during the tracking scope. However, if I swap this around and say that this effect depends on count, and we'll just make this V, and actually not the right return type because we do on cleanup returns like React now. And you say set double here on the back half when we click it, it still works. And it's not going to complain at you because, well, I don't want you to write distinct effects. This is perfectly valid. The consistency problems go away because you're not trying to do it while you're reading it. You're doing it afterwards. This applies after all of the graph is settled. Basically, we finished our reactivity, and now we're going to apply your change. This is valid. You know, like if you're reading from the DOM and you're like, oh, I need to set some signals, I'm doing some animation stuff. So it's perfect. Like, while 99% of cases shouldn't need it, you can still write to signals from effects. The split just actually makes it really clear where the responsibility is. You don't write here, you write on the other side. So yeah, this is something I found over and over again as been worked 2.0. Everything every design piece makes splitting effects seem like the only thing that makes sense to do. Like every single problem you hit, it just aligns perfectly. Yeah, I think that's a good idea once we have docs. Why even have I showed this a little bit earlier, but the reason why is because the control aspect. It's the same reason that I was like really happy that we didn't do dot value and the setter. Choosing create memo is a statement. Do you know what it is? It's const versus let. Why does JavaScript have const? We don't need const. It's not actually read only. Why is there const versus let? That is the difference. Memos are const. They're like saying like, look, you can't mutate this. That's odd. Oh, I think they're just I have like both my parents calling me. And then like it's my little guy's first birthday today. So I think that makes a lot of sense. Not destructuring set state is also a statement. Yeah, I don't know what that statement is though. It's like use callback and use memo are the same function. Yeah, I mean, yes. The problem with this is once you set something in an effect, you remove all guarantees. That's the end of the graph. A lot of people have this like weird perception that it's all like it does ping pong. The reason it ping pongs is because like you basically broke the chain. Double has no idea what its sources is. So when you're reading double down here, it doesn't know like if it depends on like if this was async, like it was doing some async work, it doesn't know it depends on async. So it doesn't know if it's stale. You broke the chain because like the effect knows it depends on count. Double doesn't know it depends on count, right? I mean, the reason this feels so silly is that like the solution for all of this weirdness that we're doing here was always because even you had this come up with an initial state that it matched, right? Like the solution was always just count times two, right? Like why are we even talking about this, right? Ta-da, like it's the problem is people think differently, right? We're inclined often to go imperative. And I think AI is like this too. They're just like, okay, I got to do this, then this, and this. I call it the shopping list. So there's a question is like, should you just go along with that? There's one philosophy that you should like maximize people's way to do that. And if you can come up with the right abstraction piece, you can do that. I mean, in fact, React is a bit of that because they're saying, look, the whole component reruns. You can write whatever garbage you want in here, and we'll do something at least reasonable with it, right? But the alternative way of doing it is like if you can apply a little structure, you've now eliminated a whole class of issues. Thank you for the birthday wishes. Yeah, Luca probably doesn't have much knowledge of anything I'm doing right now, at least, but you might hear him crying in the background here and there. He definitely tries to get in my office when the door is closed. Uh, almost walking. All right. Okay, so where are we here? Yeah, so the weirdest thing about talking about it this way when trying to break stuff is like I have to start from where people are at, like patterns and stuff in React. Whereas if I started from scratch, you wouldn't it's actually easier to do the right thing than the wrong thing. But people don't know to do the right thing. So that's going to be the gap coming here. What's going on? Sorry. Yeah, that's what I thought. All good. Getting Discord messages doesn't matter. Okay, so let's continue. I think this is most of like what I wanted to show on the warning stuff and about so people going to get the effect stuff. I've also spent a bit of time showing off the async stuff. I want to take things a little bit farther here. I'm a little bit disappointed about the warning stuff. I'm gonna have to find a pattern or stuff to fix the warning issue. But the other thing that I did um, here is this template is good for just playing around, trying all the new features. Is there anything that people are particularly interested in? Drop it in chat. I might not pull it up right away, but if you do have any questions or things you want to see, let me know. But otherwise, there's something that I want to try here, and I'll show you that in a second. Let's go back to our dashboard, and I'm just going to delete this clone because I don't actually need it for anything. So let's continue. I also need to update this one, but I also made a very basic SSR clone. This one probably buggier because it's doing SSR with hydration and whatnot, but it is a similar template. Let's go to beta 1, save, just Vite. But Vite's pretty powerful, which is sweet because I was able to set up like the simplest app where, is index even used anymore? Yeah, I think this index is a miss, is actually garbage. Oops. The way I set up this app was entry client calls hydrate on the document, entry server calls render to stream. There's some manifest business here, and then the app is literally just a full HTML, JSX HTML page with a signal that swaps the page. So when I switch, I think there's a loading boundary. That was a lazy component. We're just testing some features, but generally speaking, it just navigating, does HMR, hopefully. Yeah, good. So SSR HMR works. And it's server rendered. I made like a simple silly routes example. So let me share this example with all of you. So this is another template you might want to work off of. So Performance 19 good enough is for like versus still below it, or what a big diff in the compiler. I mean, okay, that's a fair question. And I want to talk a little bit about this because I haven't performance tested Solid 2.0 basically at all. My last time I tried it, it's funny, my initial version before I added R3, which is theoretically a faster signal library, like in the JS framework benchmark, we were actually slightly ahead of where Solid was today because we fixed the memory issue. So it was like, but then when I switched to R3 and new versions of Chrome came out that were slower, we actually end up like 0.01% behind Solid today. So I consider it a win though, because the reason I consider this a win is when you consider that the way Solid 2.0 works, where everything is basically a transition, it's let me like the goal of Solid 2.0 was to do async, and I'm gonna get away from benchmarks and talk about the compiler in a minute, but it's related. So I'll talk about it here is what I wanted to kind of point out here is if Solid, wherever it is, where are we right now? I can't even. Oh, did we not? I guess we didn't. Oh no, here it is. Solid's right here, right? Okay, sweet. 1.111. So maybe like let's pretend the new version is 1.12 right now. I'm hoping to do some performance improvements on it, but let's actually let's focus in on React for a second to hopefully help answer this a little better. So not which frameworks, none, and then let's just compiler, hooks, use transition hooks. Yeah, these are the three I want to look at. Now, React hooks implementation, originally written by me actually, little thing. It's been improved over time, so I'm thinking, but I think I was one who actually originally did the implementation for it with a little help from Dan Abramoff. Um, Super hand optimized, understand exactly how renders cycle works. Very, very thing. Compiler version is removing all those hand optimizations but keeping it structurally the same. Usually these versions are very close. Something in the thing showed where it shows that the compiler is actually like slightly slower than the hand optimized. I'm surprised by this. I think this is variance. I think between different versions of stuff, they should basically be the same. The one I want to highlight here is use transition, which is where when we wrap everything in transitions, is like almost two. It's like 30% slower. And the reason I want to bring this up is that Solid 2.0, because we're not using a compiler trick to do the transition stuff like Svelte to handle async. We're not like looking at that. We're literally doing a runtime thing. It's kind of like the use transition version of this. So I actually had a really tough challenge because I had to make the use transition version as fast as the not use transition version, essentially. In React, there's a gap, like a significant gap here. And in Solid 2.0, we've actually succeeded, basically allowing the use transition abstraction to basically not cost anything. Now, is there a chance it'll be slower than Solid 1.0, like by a fraction? It is possible. I'm hoping that the other improvements will actually balance it out, but it is a consideration here. And for people who don't want this async behavior in transfers, like, why did you ruin the performance by 0.001% or whatever just to get a feature? I think, as I said, I think that feature is really important. But I wanted to kind of point out the two things here. Even if we take a hit, it's for a very good reason. And in the scheme of solutions, it's incredible. It's like pretty impressive feat of engineering to actually get this without a cost when it's purely runtime. How solid work is it easy to add single ripple? I mean, people have done this before. There's compiler things. So, like, was it solid labels? I'm gonna finish your other question, the other question in a second here. Solid labels, GitHub. There we go. Yeah, it's just it's SolidJS labels. So there's like, I mean, there's different kinds of things. Like this is a library that was released like 5 years ago. It's kind of funny because there's only so many places you can go in the design space when designing these things. So the fact that Svelte runes and ripples kind of stuff kind of looks similar to something that we released years ago is not surprising to me, but it's still kind of it's still, you know what I mean? Like it's not like we didn't consider it. So the answer is yes, you can do this. Do I think it's a good idea? No, not at all. But you can definitely do this. Which is getting to the thing. Benchmarks will never show you the value of the React compiler. Which is where I mean, I'm trying to think. I mean, I could go on it, but I've done actually two whole streams on why I don't think it is. I can link it. I think, I mean, I'll link those, but I will also give you a short answer as well. The short answer is that what you're gaining in syntax is not worth it in either complexity and masquerading what's actually happening under the hood. You're killing transparency. Like the thing is, if you can use it to optimize, in a way, I will accept that. But generally speaking, doing it for ergonomics is, I mean, there's places where you can maybe encode restrictions, which would be good. Do you know what I mean? Like when I first saw Svelte stores, I was like, or like their equivalent to our stores. I was like thinking like maybe they would not allow them to be mutated outside of the file or something, but they changed that to do that anyways because of like they felt it was too clunky. But like the compiler can do some stuff that's like pretty powerful for restrictions. But if that's not what you're doing it for, and if you're not doing it for optimizations like that are actually necessary, then like the you're not like you're saving someone a couple characters for basically nothing. Now, if it is the core to how your approach works, and you know the ergonomic boundaries are a big deal. Like Ripple needs this to in order to like make the ergonomics match with the experience, then I think that's a perfectly fine argument. I just since I have literally no need for it in Solid, I have no need to to do this. Yeah. So like I mean, where do I want to start? There's Solid script using compilation for syntax from what's this is a decent like overview of the positive sides of things that I was thinking about. This is I did that stream like 4 years ago, a long time ago, and then I did one more recently. There's also the cost of building a language, which is a really good stream. If with Dylan, which building you this is one of my favorite streams of all time because it makes me really it's both incredible what they've accomplished, but it also makes me like hate the idea of building your own language compiler. Like in terms of it really highlights what the overhead is. And then um the last one is um I had a second script reactive script one I thought, but I'm not seeing it at the moment. Yeah, here it is. Revisiting solid script, reactive compilation. Yeah. Again, I don't expect people to have the time to do it, but hopefully the timestamps can highlight it on any key points people might be interested in. Yeah. I mean, there's reasons people do stuff or design certain way. This is just my opinion on the thing. It basically adds the most minimal value at a cost that I'm not willing to pay. It just doesn't, from my perspective. Okay, so back on why the React compiler, 5% improvement, like really just quickly here, is because it doesn't make React faster, it makes your code faster. It's basically it does two things that are really powerful. First of all, it basically adds all the memoization in so you don't. So if you miss memoizing every last callback or whatever, it's probably better at it than human error involved. And the second thing it does is it forces you into a stricter structure, which is very in line with what I'm talking about here about temporal determinism. Like strict React is less likely to get you in trouble. So the compiler kind of guide you along that path so that like you do the right patterns. Both of those things will drastically improve the performance of your React app, but they don't make React faster. So like basically, I know Joe Savannah doesn't like this. He did a whole talk where he was like, "Oh, the compiler doesn't make it faster." Well, look at this; it makes it faster. And it's like knowing how the compiler works. I'm pretty sure while no one would actually do this outside of a benchmark, but everyone always does this in benchmarks, like you could write the same code by hand without the compiler and it would be as fast. Do you know what I mean? Or maybe even faster because you could specialize the case. That's the problem with benchmarks. People write the most, they don't always write the most idiomatic thing. They write the most like performance focused version to get the best results. And there's a good reason to do that because like pretend I am writing a benchmark and I have solid and svelte and a whole bunch of stuff and I put React in. If I don't go 100% to make sure React is as fast as I could possibly make it, someone could point a hole and say, "Oh, you're not being fair to React." Someone might look at it and go, "That's not idiomatic React. I think you should like do idiomatic," and you're like, "But then the performance would be worse." But me not being a representative of React, I have to, if I had to choose between idiomatic and most performant when representing in a benchmark, I generally have to go most performant, right? I actually asked this question a couple times, like the Svelte team when I was working on this. I was all migrated to the Svelte 3 benchmark, and I'm like, "Do you guys want the fastest version or the idiomatic?" And the Svelte team was like, "Idiomatic." Mad props to them because that's what they care about, but you don't always get an answer and you have to choose that. So from that perspective, benchmarks are never going to do it. And even like the React team was like, "Oh, look, we have a benchmark showing it." they're showing idiomatic code versus the thing, which is I think a better real world comparison. But the truth of the matter is, anyone who's catering stuff to benchmarks will have already made React faster. So then like you see like a 5% or basically no difference. Faster or equal at worst, yeah. Um, yeah, there's some planning around like backporting some old primitives, but we don't need create a resource anymore because literally every case is just natively handled by the signal system. So Solid will be comparable faster to compiler or like more. No. I mean, Solid's already way faster in benchmarks than it. So I just was trying to show that with Solid 2.0, it's like we have our own transition version. So it might lightly, like fractionally, impact the performance compared to Solid 1.0. But like we're you like we're sorry, I didn't show this, but maybe I should show this. We're over here, like I don't know, 12 items up. React and all green. React is like over here. Preact. Am I there yet? No. Keep on going. Angular, Emba, Elm. I'm almost there. More Angular stuff. React, 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 right here. So like, I was trying to show that like, I was talking about it from two purposes. Sorry if that was confusing. Um, no, not really. Like, there might be some cases specifically, but the the thing is React's render model. I don't want to. I want to get off talking about React because like I've covered this before. I was hoping that I'd just do it quickly. But I'll just say not really, no. And without trying to explain it, we'll just continue. Sorry, I it's just because I've talked about this a ton in the past. Okay. Well, what I wanted to do, I forget how I got sidetracked to that, but what I want to do actually is I want to look at the SSR example and I want to start doing some fun stuff. So let's fork this. Did I post the SR? I've one of the things that I thought would be fun to do is we can get rid of this lazy component. This is, let's just delete that. I don't care about this routing stuff. Let's just, only thing that I'm gonna pull this. The one problem with this setup is this file can't reload because, or it's a full reload because it's literally the head of the document. It's like all in the server. So what I'm gonna do here is I'm going to just kind of like gut the reactivity out of this, and then we're going to move our actual code into something else. Let's just make another file. We'll call it, I guess we can just keep on using home. Let's just keep on using home. All right, if I use home here, looks like it's still possible for me to kill HMR sometimes. I don't know. Well, I'm still getting my hang on it. Okay, that's fine. So now we have that. Now we have home. Home updates. Yeah, okay, we're good. Without doing a full page refresh. Yes, it does. Okay, sweet. Now we can do some work. Let's go to work. Um, yeah, I mean, we covered that like 20 minutes ago, but the short answer is, and and the short answer is that we want to know all and I actually covered it at the beginning of the stream too. We want to know all the dependencies up front before we run any side effects. It's super important for an async first model. Brennell's already made it. The funniest thing is, we don't have the full SSR single flight mutation version, like the full picture, but because we haven't done it like with solid start and server functions yet. But the thing is that mechanically it looks like that to do MVC I made. We basically crushed the whole demo into a single primitive, the create optimistic store, that basically just handles everything. So Strello was again, Ryan Florence, best demos. This Strello was really instrumental for us because it really gave me an idea of how projections and stuff should work. I wanted to make it so that anybody could literally make a Strello demo like this and get the right behavior, and that's what we've accomplished. I could try and go digging for Brenly's version. If he's still around, he could share it. But it's not all that different in a sense from the to do with affordance example that I was showing earlier. Okay, so what do I want to do here? Well, let's do a couple things. First thing is let's create some reactive state const. Actually, you know what? Let's just jump straight ahead. Let's create some data, and we'll make a memo, and our data will be 5 for initially, and then we'll just do something like put it in our document data. Okay, sweet. Home 4, sweet. Now we're not surprised about how any of this works. Okay, so let's up our ante a bit. Let's make this get data, and let's return new promise, resolve, set timeout, sorry, I needed that, set timeout. Actually, I think I can do a shortcut. I can go like res 1 second, and then what I want to set it to, which will be 4, I guess. Actually, we'll set it to 5, so just in case. And then we should be able to just change this to get data. So now it's coming from the server. That's cute. What was cute about this, that I thought was cute about this, is did you see that the HMR automatically handled it? It like actually loaded the 5 in. But you'll notice something. First off, the page is blank for a minute. And the reason for this, oh, what's wrong with this? Oh, right. We should be more clear what we're doing. String number. Sorry. TypeScript's great. So you're like, oh, crap. It's blank for a page for a second. Well, the reason it's blank is because it took the server a second to respond to getting this data initially. That's the reason why you don't see it, right? Because we now support top-level data fetching in 2.0. This is one of those things, right? We didn't break it just because I added it. I mean, this kind of sucks. To be fair, this is like Next.js back in 2020 or something. Or like Remix in 2020, or almost every JavaScript framework except Marco in 2020. You do this thing where you prefetch some data. I mean, it's nice that we can just fetch it in our component, but we're not sending anything onto the whole page load. So, I mean, what should we do here instead, right? I don't want to wait that long. I think a smart thing to do here might be to wrap this in a loading indicator, right? Because I was trying to think of what I needed, but loading feels like something natural. And then ironically, we'll just put loading in here. And then